Hello again, everybody. We're looking right now at some Topic 12 notes yet again. We start off with a couple of vocabulary terms that are going to end up being very important as we look at today's notes. Okay? The first one is the word inscribed angle, and that is what happens when you have two chords that have one endpoint in common and they form an angle on the inside of your circle. Okay, so as you look at the picture as you look at the picture that's printed on your page right there, the inscribed angle is what is formed right here. Okay, this angle right here is the inscribed angle. Okay, in this situation, the chords that make it up are A, B, and BC, and it creates the angle ABC. Okay, so that's what we've got there. And the next term is our intercepted arc. Okay, that is what happens when the two chords of an inscribed angle intercept the circle. Okay, and this is the opposite endpoints, the ones that they don't share. Okay, so these two chords, A, B, and BC, form an angle at point B over here, but they also form an arc at these other 2 points, A and C. Okay, this arc right here in this picture, arc AC, is the intercepted arc. So as we go along through this section, that's what we're going to be talking a lot about today is inscribed angles and the arcs that they make, the intercepted arcs that they create. Okay, so our first theorem tells us that the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so in this situation, your inscribed angle is this angle down here that goes from A to D to B. That is the angle that we're talking about. And according to this theorem, if you have the measure of the arc, if you have this bit over here that's 88 degrees, okay, we have angle ADB as our inscribed angle. And according to this theorem, that angle should be half of the arc measure. Okay, so it's going to be half of 88. And so that's how we end up with a measurement for that angle. Measure of angle ADB must be 44 degrees. All right, so you'll have some problems that look kind of like that. Pretty simple stuff. Go on now to our next theorem. It's actually not a new theorem itself. It's what's called a corollary. That just means that it's related to the original theorem. It's another statement that you can get based on that original theorem. Okay, so this says that if two inscribed angles intercept the same arc, then the angles are congruent. That's the word you'll fill in, congruent. Okay, so as you're looking at this, it's kind of difficult to tell, but we've actually got two angles in this picture that we're talking about. Okay, angle ADB is the first one. Okay, that's the angle I just outlined in orange. And our other angle, I'm going to outline in blue, is angle ACB. Now, both of these angles, when you look at them, when you at least look at their naming conventions, they go from A down to another point and then back up to B. And so both of them end up with the same intercepted arc. Okay? Even though those angles are separate from each other, they both have the same arc AB. Okay, that's what that is. It's arc AB is that intercepted arc that they both have. Okay? And so according to that theorem that we just wrote down, the theorem says that the angle with that arc, the angle should be half the measure of that arc. So if you ignore the blue angle for a second and you're just looking at the orange one, you would think, well, that angle ADB should be half of 50 degrees, so it would be 25. And you would be correct. But if you ignore the orange one and only look at the blue one, you would think the exact same thing. Okay? Both of them are correct. Okay? Since they have the same arc, and that arc is as the same measurement, okay, as itself, obviously, then those angles are also going to have the same measurement. All right? So those angles are going to be congruent to each other. Go on now to another corollary. Again, it's another statement based on that same theorem that we had at the beginning. It says that if an angle is inscribed in a semicircle, it's the first thing to fill in, then it is a right angle. Okay, I want you to think about for a second why that makes sense. Okay, when we think about a semicircle, okay, what I'm going to do is I'm going to highlight right here, going from A around to B. It is a semicircle. In a different color, I highlight this. Both the top and bottom parts of that circle are half of the circle, right? That is a semicircle. So when you have an angle up here, angle ACB, well, you think about that theorem that we just had. The theorem that we said, okay, the basis of that entire theorem was that the angle is half of the arc. Well, y'all, on a semicircle, the arc is 180 degrees. It's half of the circle, so it has to be 180. So if you're saying that the angle is half of the arc, of course it's a right angle. It must be a right angle. That's the only way this could possibly work, because the angle is half of the arc. So if the arc is a semicircle, you must have a right angle inscribed in it. Going on now to our last corollary, it says this. It says that if a quadrilateral, that's the first word to fill in, is inscribed in a circle, then its opposite angles are supplementary. Okay, supplementary is a word that we have not heard in a while. Quadrilateral is something you probably remember even if we haven't heard it in a while. Okay, quadrilateral just means it has four sides. But that term supplementary is something we have not talked about in geometry for quite a while. Supplementary means the two angles add up to 180 degrees. Okay, so when you talk about opposite angles, in this example, that's talking about angle A and angle C are the opposites. Angle B and angle D are the opposites. So when it says that they're supplementary, that's saying that A plus C equals 180. That's saying angle B plus angle D equals 180. So when you consider that, there's something very important that we can draw from this, and that is the following, okay? And this is what you're going to fill in the box on your page. The sum of all four angles is 360 degrees. The sum of all four angles in your inscribed quadrilateral, let's try saying that 5 times fast, is 360 degrees. Looking at a new theorem now, not just a corollary based on the old theorem, but you are going to see that this theorem is very similar to the last one. It says that the measure of an angle, this time an angle formed by a tangent, that's the first thing to fill in, angle formed by a tangent and a chord. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. Okay? So the basis, the simplest possible way to talk about this theorem is just like the previous theorem. Okay? Pulling it down to its most basic root form, you say that the angle is half of the arc. Okay? It's just another theorem that talks about the angle that is half the arc. However, as we talk about this, make sure you know what angle we're talking about. Okay? In this case, we're talking about the angle in between a tangent and a chord. In this diagram, the line DE going across right here, this is your tangent line. And we know that because it only intersects the circle at one single point right up here, point C. Okay, that's your tangent line. And CB is the chord that's in this diagram. So when we talk about the angle between a tangent and a chord, we are talking about this angle right here. Now, according to this diagram, the arc that's cut off by this chord is 80 degrees. It is an 80-degree arc. So according to this theorem, and based on the stuff in this diagram, we know that the measure of this angle that I marked off in purple is 1/2 the measure of that arc. So all we're doing is taking 1/2 of 80. Okay, and that's how we know that angle ECB up here is a 40-degree angle. Now here's the question. What does that mean? What does that mean for this angle? Angle DCB. Okay? I want y'all to think back to way back closer to the beginning of the year when we talked about a linear pair of angles. Okay? A linear pair of angles is when you've got two angles right directly next to each other that make up a straight line going across. And I'm looking at line DCE as a straight line that goes across here. Line DCE that's made up of two angle parts. It's split into two parts, and y'all, we just have to remember that a linear pair, a straight line, a straight angle is 180 degrees. So if we already have this side and we're looking for this side, we can just subtract it from 180. 180 minus 40 will give us that green part, and that green part is going to be 140 right there. Okay, that's going to come up on some of your problems today as well. So with all of these theorems and corollaries and everything in mind, let's talk about this example. Okay, this example is asking us three different questions. It wants us to first find the measure of angle ABC, then find the measure of arc CB, and find the measure of angle DCE. Okay, so there's a lot of stuff going on right here. Let's dissect it a little bit. First thing I see is that angle ADC, so that's talking about this one over here, is 70 degrees. We also see that down here at the bottom of the diagram, this going off, this going off to the side over here, that is down at the bottom of the diagram, that is a tangent. Okay, so that's going to end up being important here in a second. So let's talk about the other things that we see in this diagram. What I see, and I'm going to outline it for you so you can see it too. This right here is a quadrilateral inscribed inside of our circle. Okay, it's got four sides, and all of the corners of that shape, all of the vertices are on the circle itself. So here's what we know about that from just a couple of pages ago, a couple of things ago that we wrote down. We said that all four of those angles should add up to 360 degrees. That's going to be important here in a second. And here's something else we know. Okay, here's something else that I see. This right here, when we go around from D to B, is a semicircle. Okay, DB itself is a diameter that cuts this circle in half. So what I just highlighted right there represents 180 degrees. Now y'all think back to our very first theorem of this section that said the angle is half of the arc. Okay, when you have an inscribed angle in here and the arc that's created is this pink arc, 180 degrees, then the angle must be a right angle. This has to be 90 degrees. When you look at it up here too, the top half going from D through A to B is also 180 degrees, so this one must be 90 degrees as well. Okay, both of the angles at the top of the picture and the bottom of the picture must be 90 degrees. And if we are going to think about how all four angles add up to 360, all you got to do is add them together and subtract it from the total. It ends up just being 360 minus 250. And that's how we get our answer at the end of this. That's how we get our answer that angle ABC must be 110 degrees. Okay, so that's the first, answering the first question right there. Let's go on to the next one, the measure of arc CB. Okay, I want to draw your attention to what I drew down here, this pink arc. Okay, we agreed just a moment ago that the pink arc was a 180 degree arc. It's half of the circle, so it's half of the full 360. Okay, we are already told that this side of it, in between D and C, is 110 degrees. So with that in mind, really all we have to do is find this missing piece that I just highlighted in green. all we got to do is take that 180 and subtract the part we already know. So we subtract 110, and that leaves us with our last piece over here. It must be 70 degrees. Go on now to answering our last question, angle DCE. I'm going to go ahead and outline the parts of that angle in a darker blue here. Okay, we're talking about this angle right in here, angle DCE. Okay, as we look at that angle, I think back to our second theorem that we had right before this slide, actually, just a couple minutes ago. We said that the angle is half of the arc. Okay, and this time it's talking about the angle in between a chord and a tangent line. So the angle is half the arc. Well, we already said just a second ago that the arc is 110 degrees. The intercepted arc is 110. So if we take half of that arc, half of 110, it gives us our angle, 55 degrees. As you're looking at your problems, make sure you know what is being asked of you, okay? Make sure you can look at that diagram and figure out clearly enough. Try and figure out what is the good information and what's the bad information, okay? It'll do you some good. Let me know if you have any questions, and I'll do my best. Y'all have a good one.